The main idea is that matter cannot be created or destroyed in a chemical reaction. So let me give you an example. Let's say if we react methane gas with oxygen. So let's say if we have a closed container and we're going to mix 16 grams of methane in this container. We're also going to place 64 grams of oxygen gas. So the methane and the oxygen gas, they cannot leave the container. They're stuck there. Now, as the reaction proceeds, it's a combustion reaction. It's going to produce carbon dioxide and water vapor, depending on the temperature. Now, let's say if you collect 44 grams of carbon dioxide. According to the law of conservation of mass, how many grams of water should you expect to be present at the end of this reaction? Now think of the total mass of the reactants. The reactants are the stuff on the left side. We have 16 grams of methane and 64 grams of oxygen. So therefore, we're starting with 80 grams of reactants. So before the reaction, we had 80 grams of matter. At the end of the reaction, according to the law of conservation of mass, in a closed system, you should still have 80 grams of mass. So if we have 44 grams of carbon dioxide, the remaining amount of mass should be water. 80 minus 44 is 36. So therefore, we should expect to collect 36 grams of water. And that's the main idea behind the law of conservation of mass. If you have 80 grams of material inside the closed container before the reaction, then when the reaction is complete, you should still have 80 grams of matter inside that container. In a chemical reaction, the only thing that's happening is that the atoms are rearranging themselves. Here, carbon is bonded to hydrogen, but now it's bonded to oxygen. So therefore, the total mass should remain the same. The atoms are simply switching partners. They're just rearranging themselves in this chemical reaction. But the amount of mass, the quantity of matter, should still remain the same.